Hello viewers, welcome to the session on K-means clustering in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. So firstly, let us look at the definition of K-means clustering. It is nothing but one of the most simplest and popular unsupervised machine learning algorithm. And in this method, we identify k number of centroids and then allocate every data point to the nearest cluster while keeping the centroids as small as possible. So let us now clearly understand the algorithm that works behind the k-means algorithm. So firstly, what we have to do is we need to decide the number of clusters. Imagine that we are having a data set in which the data points are arranged in this manner. We need to cluster these data points. So firstly, we need to decide how many clusters we need in this data set. So let us suppose the k value is given as 3. Then after that, the next step is to select at random k points. We assume that these are our centroids. This can be the same data point or any other point in this graph. So for example, we have taken the k value as 3. Then we can assign any for randomly. I am selecting this point and this point as my centroid. Then what does the next step is to assign each of the data points to the closest centroid. The centroid which we have firstly assumed as centroid, then we will assign each of the data points to its nearest centroid. After that, we again take the whole cluster and compute its centroid. The fourth step is we consider the whole cluster and then make its centroid. And we keep on repeating this unless we reach to this point where we are getting finally all the required clusterings. Now consider this scenario where we are having a same data set and we want to cluster it into 3 clusters. And we have assigned the value of k as equal to 3. Now what happens in k-means is we are randomly selecting the centroid. Let us suppose I have chosen a centroid at here and here. Then my 3 clusters will be of this type. But whereas consider the another scenario for the same data set, if the randomness centroid is I have chosen here and here, then the same arrangement is different here. To overcome this drawback, we have upgraded k-means into k-means plus plus. So let's look at how it works. So now let's look at the algorithm of k-means plus plus and understand it clearly with an example. Before that, let's quickly have a look at the algorithm first. What we do here is we choose first cluster center uniformly at random from the data points. Means at a random I select any one of the centroid randomly, it can be anywhere. And for each observation x, compute the distance d of x to the closest cluster center. After that, what we do is, let me first clear the algorithm, then I will explain you with this example. Choose the new cluster center from amongst the data point. Among the data point, again we have to choose the new cluster center with a probability of x being chosen proportionally to d of x square. And we need to repeat these steps until we get k cluster. So let us suppose we are having data points like this and I have assigned the k as 3. Then what does k-means plus plus does is initially it randomly selects any one of the centroid, and suppose I have chosen this square, and then it calculates the distance to each of the data points, and it will do the square of it, and it will consider the largest distance between any of the data points from each centroid to the next one. The largest distance between 2 data points, and here we have find, for suppose we have from here to here, we have find the largest distance between them. So my next centroid will be this point, and again from this point we are going to repeat the same step. We will calculate the distance between other data points and we will look for a data point which is having the largest distance. Obviously it will be the first will be this one, but it has been already considered, so it will look for another data point which is farthest from it. So suppose we have found this as our new centroid. So firstly we will assign all the centroids and after that, according to the distance that we have calculated, the distortion distance, and that is nothing but the distance between them and square of them, summation of them. After that, we will assign each of the data points to its nearest centroid. This is the working of k-means plus plus. So now the question is how to know the exact number of clusters for a given data set. For a smaller data set, just by looking at it, we were able to decide what could be the number of clusters. But for a big data set, we need to take the help of elbow method. What we do in this elbow method is just we plot a graph between distortion and number of clusters. What optimal number of clusters we may find, that within what range number of clusters can lie. We take that in x-axis, and distortion is nothing but the distance from the centroid to the each data set point, what we have discussed in the earlier slide, and squaring of them. That is what it is. The plot, it is a graph plot of the same thing, line plot. So what we are doing here is, see, on the y-axis we are having distortion measure, and on the x-axis we are having the number of clusters that can be the optimal for a given data set. So from this graph, what we have to infer is we will find a point after which the distortion is minimum. Now suppose you see from the first point to second point there is a huge distortion gap between them. Again from second to third there is again a huge distortion gap. From 3 to 4, okay, from 3 onwards it is almost, the distortion is almost negligible, not negligible but almost very less. So we will choose 3 as our optimal number of clusters. This is the main method, elbow method, which we use to determine how many optimal number of clusters can be possible for any size of the data set. So let's quickly look at the pros and cons of k-means algorithm. When it comes to its advantages, k-means algorithm has linear time complexity and it can be used with large data sets conveniently. This makes it high performance. And default parameters in the scikit-learn implementation makes it a simple algorithm. And if our data has no labels or even column headers, k-means will still successfully cluster our data. K-means returns clusters can be easily interpreted and even visualized. But on the flip side, when it comes to its disadvantages, k-means generates only spherical clusters. In most of the cases, n clusters needs to be optimized, adjusted and reassessed at least a few times, involving manual work. One of the inconsistencies of k-means algorithm is that results will differ based on random centroid initialization. So finally, it's time for your favorite hands-on session on k-means plus clustering in machine learning. So in this practical session also, I am importing all the important libraries. Let me explain you with the help of a data set what we are going to do in this practical. So the data set is containing 3 attributes: age, annual income and CIBIL score. This is actually a normal data set which is containing 200 records, and it is related to a store customers, and the store manager wants to cluster his customers in such a way that he can have an idea that these all people belongs to a particular cluster. There is some relationship between among that cluster based on the annual income and CIBIL score. So in order to help that manager, what we are doing according to him, we are segregating our variables as annual income and CIBIL score. See, it has been successfully executed. Now we are going to help the manager by telling him what can be the best possible ways of clustering he can do by making use of elbow curve. For that, what we are going to do is, from sklearn package and cluster module, I am importing k-means class. And as we have discussed in the theory slides, here I am creating firstly distortion empty list, which is going to store all the distortion values. And just recollecting you, what is distortion? It is nothing but the square of the distance, and it is going to append it every time when we are going to run the loop. And I will explain these two lines again. This is the main algorithm for the k-means. First, let us find the elbow curve so that you can have a complete idea. Then I will explain you about these two lines. See, the elbow curve has been plotted successfully. Now from the curve, what can you infer is that here there is a lot of difference. Let me enlarge it so that you can have clear view. See, what is this plot telling us is that there is a lot of distortion up till here, but after number of clusters at 5, the distortion is relatively very less. So what we can suggest the store manager is that the best number of clusters can be of 5. So what I am doing is I am creating an object of k-means class. The parameters that we need to give to the k-means class is that we have to provide the number of clusters, which is nothing but 5, and the method which we are going to use is k-means plus plus. Init equal to k-means plus plus. It is best then random, and random state equal to 0, and I'm predicting all this through k-means.fit predict of x and storing it in y cluster. Let me execute this chunk of code, then you will have a clear idea. See, it has been successfully executed. Now the y cluster is going to have the clustering number of each of the customers. See, it is containing 200 records, and it has successfully classified the customers into 5 clusters. You might be thinking the largest value is 5. This is because we are starting from 0 to cluster to 0, 1, 2 and 3 and 4. So in total there are 5 clusters has been successfully executed. So let us visualize this cluster. Before that, let me explain you what we are doing. First, we are doing the scatter plot of all the customers who belong to a 0th cluster, and I am making this color as red and labeling it as cluster 1. Let me show you a demo just by running this line. See, this is the plot of only of the customers who belong to cluster 1, cluster 0. Similarly, now let us plot for cluster 2. This is the graph of cluster 2 customers. Now what I am doing is, after plotting the clusters, I also want to tell the centroid point of each of this cluster. So what I am doing is, k means cluster center is containing the coordinates of centroids of each of these clusters. And let me execute this chunk of code and explain you clearly. See, I have selected all this line, and I am using legendary plot. This is because I want to display these labels also, and the centroids are in yellow color. So our 5 clusters are of red, brown, green, blue and orange colors. Let me execute this chunk of code. You will get a clear idea. See, it has been successfully executed. See, the dataset has been divided into 5 clusters, and the yellow represent the centroids of each of these clusters. So as usual, I have included code snippet for your fast revision. So you can pause your video right here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you, and hope you have gained something extra than what you were knowing earlier. Thank you.